Hello and welcome to this walkthrough video for my Edexcel Foundation Paper 2 practice paper. If you want to give the paper a try, you can find a link to it in this video's description. You'll also find a link to my website where you can find other practice papers and also revision topic lists for paper 2. So for this first question we need to write 0.03 as a fraction. So if we look at the second of those zeros there, that one's in the tenths column. Then this 3 after it must be in the hundredths column. So what we've got here is 3 hundredths. So you can write that as 3 over 100. For the second question we need to round 4,578 to the nearest 100. So first of all we find the number that's in the 100ths column, that's this 5 here. Then we can draw a line after that 5. And then we check the next number just in case we need to round up. So this number's a 7, which is a 5 or more, that tells us we need to round up. So the 5 that's before the line will actually need to increase to a 6, and then all the remaining digits can become zeros. So if that 5 goes up to a 6, it's 4,600. For this question we need to convert 7 litres into millilitres. You should know that 1 litre is the same as 1,000 millilitres, so we just need to do 7 times 1,000, which is 7,000. To write 1/5 as a percentage, we're going to take our calculator and type in 1 divided by 5. That will turn 1/5 into a decimal, which is 0.2, and to turn any decimal into a percentage you can just multiply it by 100. So 0.2 times 100 gives you 20, so the answer is 20%. In question 5 we've been given some numbers and we need to find which one's the prime number. So prime numbers are numbers that have exactly 2 factors. So the first prime number is 2, since its only factors are 1 and 2. Then it's 3, the only factors of 3 are 1 and 3. Then it's 5, since the only factors of 5 are 1 and 5. 5 is in our list, so 5 must be the answer. Then we need to write down a square number from the list. So to get a square number you can just times any number by itself. So let's start with 1 times 1, which is 1. That's not in the list though. 2 times 2, that's 4. That's not in the list either. 3 times 3, that's 9. And there it is, 9 is in the list, so the answer is 9. For the final part of the question, we need to write down a multiple of 10. A multiple of 10 is just a number that's in the 10 times table, not to be confused with factors of 10. Factors are numbers that fit into 10, or divide into 10 without a remainder. So the multiple of 10 in this list is 20, since 20 is in the 10 times table. For this question, we need to write down the next term in the sequence. So first of all, let's work out what we do to get from one term to the next in this sequence. In all of the cases here, it's subtract 4. So to work out the next term, we're just going to take away 4 from the last one, so 1 take away 4, and 1 take away 4 gives you negative 3. For the next part of the question, we need to explain how we got our answer, so we can just say we took away 4 or subtracted 4 from the 4th term. For the final part, we need to work out the 10th term of the sequence. So we're already on the 5th term, that's negative 3. And then we can just keep going by taking away 4 each time. So if we take away 4, that's negative 7. Then again, that's negative 11. Again, negative 15. Again, negative 19. And for the final time, the 10th term, negative 23. In this question, we need to simplify. So when you multiply terms like this with algebra, we're first of all going to multiply the two numbers. So 5 times 3, which gives you 15. And then we need to multiply by f and g. And all we need to do here is just write fg. So when we have terms multiplied together like this, you don't write the multiply sign. For the next part of this question, we've got k times k squared. Now k squared means k times by k again. So let's replace the k squared with k times k. Now we've got 4 k's times together, so k times k times k times k, which must be k to the power 4. For the first part of this question, we need to write down the name of the shape. So you should spot we've got 2 pairs of parallel sides here. The top and bottom are parallel, and also the sides here, the left and right side, are also parallel. If you've got 2 pairs of parallel lines there, and it's a 4-sided shape, that's called a parallelogram. For the second part of the question, we need to work out the area of this shape. To work out the area of a parallelogram, you need its base and its perpendicular height. So we can count the squares for the base, that's 6, so it's 6 centimeters along the bottom. And the height of the shape is 2 squares, so it's 2 centimeters. So all we need to do is 6 times 2, which gives you 12 centimeters squared. For the first part of this question, we need to work out the area of the triangle ABC, and we need to give the answer in square meters. Now that's okay because all of our lengths in the question are in meters. To find the area of a triangle, you need to do half times the base times the perpendicular height. So let's look at the base of the triangle. Well, that's from A all the way to C, so we can add together this 30 and 15 to give you a base of 45, and you can already see the perpendicular height there, that's 20. So to find the area of the triangle, we do 1/2, which is 0.5, times the base, which is 45, times the perpendicular height, which is 20, and if you type all of that into your calculator, you'll get the answer 450 meters squared. For the second part of the question, we need to draw this shape on the centimetre grid as a scale drawing, and we've been given a scale. 1 centimetre is going to represent 5 meters. So every centimetre that we draw on this grid will represent 5 meters of the triangle. So let's take all of the lengths of the triangle and turn those from meters into centimetres for our scale. So between A and D there's 30 meters, but we know from the scale that every 5 of those meters is going to be 1 centimetre on our diagram. So if we divide 30 by 5, we end up with 6, so this length will not be 30 meters, it'll be 6 centimeters on our diagram. Now let's do the same with this length here, the 15, so 15 divided by 5 gives you 3, and also the height here, so 20 divided by 5 is 4. So we now know we need to draw a triangle, which is 6 centimeters first, and then from here another 3 centimeters, and then we also need this height which goes up 4 centimeters, and that goes here. So if we connect up those points like this, we don't actually need that dotted line, here's your final triangle. In this question we're trying to work out the size of angle CED. That's this angle here. First of all we're going to find out the angle BCE. So this angle here, BCE, is 74 degrees. We need to give a reason for each stage of our working though. So the reason that one's 74 is because it's vertically opposite to the angle ACB. So we could put a reason on here and say that this angle is 74 degrees because vertically opposite angles are equal. Next we're going to find the angle at the bottom left of that triangle, angle CDE. Now that one happens to also be 74 degrees. If you look at the triangle CDE, you'll notice it's got those two lines which mean they're the same length. This means it's an isosceles triangle, and in an isosceles triangle the base angles are equal. So we could say that this angle is 74 degrees because the base angles in an isosceles triangle are equal. Now we're only one step away from the answer, so if you look at the whole triangle CDE, we know 2 of the angles and there's only 1 left. You should know that the angles in a triangle add up to 180 degrees. So let's add together the 2 angles we have, 74 add 74, which gets you 148, and if we take this away from 180, we'll find the answer, which is 32 degrees. So the answer is 32 degrees, and we'll also pop on that final reason. So the reason for this angle was that the angles in a triangle add up to 180 degrees. For the first part of this question, we need to work out how many minutes longer the maths exam is compared to the geography exam. So in the table, you can see the maths exam is 90 minutes and the geography exam is 1 hour 20 minutes. So let's turn the geography exam's time into minutes. So 1 hour is 60 minutes, so we need to do 60 minutes plus 20 minutes, which means the geography exam was 80 minutes. So if the maths exam was 90 and the geography was 80, we can find out how much longer it is by doing 90 minutes take away 80 minutes, which is 10 minutes. For the second part of this question, we need to work out a ratio. It's the ratio of the length of English paper 1 to English paper 2. So you can see both of those in the table here. Let's turn those into minutes. So for English paper 1, we've got 1 hour, which is 60 minutes, and then 3/4 of an hour, which is 45 minutes. If you add that together, you get 105 minutes. Then for paper 2, we've got 2 hours, so 60 minutes for the first hour, 60 minutes for the second hour, and then 1/4 of an hour, which is 15 minutes. So add 15, and if you add all of that together, you get 135 minutes. So we've been asked to write this as a ratio, so the ratio will be 105 minutes to 135 minutes. But the question does say give it in simplest form. So what we're going to do is divide both of these ratios. You can divide them both by 15. If you divide the 105 by 15, you'll get 7, and if you divide the 135 by 15, you'll get 9. Now I suspect some people may not spot you can divide these by 15, but you could also divide them by 5 and then 3 for example, and you'll still end up at the same answer. So the answer is 7 to 9. For the last part of this question, we're told about Kylie. Kylie receives 25% extra time for her exams. Now her geography exam is going to start at 9:07 and she's going to use all of the extra time. We need to work out what time the geography exam is going to finish. So what we'll do first of all is work out how much that 25% extra time is. Now you can see from the table the geography exam was 1 hour 20 minutes. We dealt with that earlier, it was 80 minutes in total. So first of all, we're going to find what that 25% of the 80 minutes is. To find 25% of a number, you take its decimal multiplier, which is 0.25, and multiply it by 80. This will give you 20 minutes. So the 25% extra time is 20 more minutes. So if the exam was 80 minutes normally, but with the extra time it's 20 more, it's 80 plus 20, which is 100 minutes. So now we need to work out what time the exam finishes. Well, it starts at 9:07, and we just need to do 100 more minutes from here. So let's add on 60 minutes first, since that's 1 hour. If we added on 60 minutes, we'd go from 9:07 to 10:07. Now remember, we're trying to add on 100 minutes, and we've already added on 60, so we need to add 40 more. So if you add 40 minutes onto 10:07, you end up at 10:47, which is the answer to the question. In this question, we're dealing with some ratios. We've been asked to work out the maximum number of apples that Harriet can buy. Now if you look in the question, we've got a ratio about the cost of an apple and the cost of a banana, that's 5:2. And we've also been told the cost of one banana, that's 18 pence. So let's write this ratio out. Apple to banana is 5:2, and then we can place the 18 pence for banana underneath the banana column. Then we need to work out what do we do to get from 2 to 18. Well, that's multiplied by 9. So we also multiply the 5 by 9 on the other side, and that'll give you 45. Now this tells us that an apple costs 45p. So we're trying to work out the maximum amount of apples that Harriet can buy. Now if you also read the question carefully, you're told that Harriet has £5. And we know the apples cost 45p each, so we just need to do £5 divided by 45p. Now if you type that into your calculator, it'll give you 11.1 recurring. Now we can't buy 11.1 recurring apples, so we need to consider how many we can actually buy. We can't buy 12, so we're going to have to buy 11 of those, so the answer to this question is 11. For the second part of this question, we're told that John buys 1 orange and 1 peach, and we're told the total price for that is 63 pence, and we've been tasked with finding the cost of 1 orange. So we've got a ratio for orange and peach in the question that's 4:5, so let's write that down. We've got orange to peach is 4:5, and since we're dealing with the total price, we're going to create a total column. So the total number of parts in this question is 4 parts for orange and 5 parts for peach, that's 9 parts in total. Now that 63 pence is the total price of both of them, so we can place that underneath the 9 in the total column. So we need to work out what we multiply 9 by to get to 63, and that's times by 7. So we can times the other parts of the ratio by 7, 4 7s are 28, and 5 7s are 35. So this tells us the cost of an orange is 28 pence and the peach is 35 pence. We've been asked for the cost of an orange, so the answer is 28 pence. For this question, we need to work out the size of popcorn that represents the best value for money. So we're going to work through each of the popcorns in turn. Let's start with the small one. For the small one, we're told it's 40% cheaper than a medium popcorn, and we're told it's 95 grams. So we know how much popcorn we'll get in 95 grams, but we don't know its price. So let's look at the price of a medium one, that's £4.80, and we'll use that to work out the price of a small one. So it's 40% cheaper. So let's work out 40% of £4.80 first. So to do that, we get the decimal multiplier for 40%, which is 0.4, and multiply it by £4.80. And this gives you £1.92. So if it's 40% cheaper, it's £1.92 cheaper. So we need to do £4.80, take away £1.92, which is £2.88. So we now know the cost of a small popcorn is £2.88. Next, if we look at the medium one, you can see we've actually got the price and we know how much popcorn we're getting, so let's move along to the large one. For the large one, we know its price, that's £6.25, but we don't know how much popcorn it is. We're told it's 1/3 more popcorn than the medium one. So for the medium one, that's 150 grams of popcorn, and we need 1/3 more than that. So let's work out 1/3 of it first. To find 1/3 of any number, you just divide it by 3. So 150 grams divided by 3 is 50 grams. So if it's 1/3 more, we're going to add this on, it's extra popcorn. So 150 grams plus the 50 grams is 200 grams. So we now know that the large popcorn gives us 200 grams, so we have the price and the amount of popcorn for each of the deals. So to work out which one's the best value for money, there are lots of different strategies. So the one I always recommend is taking the price of each one and dividing it by the amount of each one. So this will work out the price per gram. So we're going to take the price, which is £2.88 for the first one, and I like to do all of these in pence. So instead of 2.88, 288 pence for the small one, and we're going to divide that by the amount of popcorn, which is 95 grams. Now you'll need your calculator for this one because it'll give you this horrible decimal here. Now we'll do the same process for the other two. So the medium one costs £4.80, that's 480 pence. Divide that by 150 grams, and that gives you 3.2. And for the larger one, it's 625 pence. Divide by the 200 grams we worked out, and that gives you 3.125. Now all of these values here on the right hand side that start with 3 are the costs in pence for 1 gram of popcorn for each of those deals. So for the first deal, it will cost you 3.0315 and so on pence per gram of popcorn. For the second deal, it costs you 3.2 pence per gram, and for the final one, it's 3.125 pence per gram. Now for the best value, you want to be spending the least amount of money, so you want the one that's the lowest number. That's this one at the top here, since it starts with 3.0. So the deal that represents the best value for money is actually the small popcorn. For the first part of this question, we need to write down the fraction of those attending Saturday that were adults. So if we look at Saturday in the table, you can see there were 357 adults and 493 children. If we're going to write this as a fraction, we need to work out the total number of people. So let's do 357 add 493, which gets you 850. So the fraction of people that were there on Saturday is 357 over 850. Now the question does say to give this in its simplest form. So if you type that into your calculator and just press equals, it will simplify it for you. So that's 21 over 50. For the second part of this question, we're told that Taylor says, on Saturday the proportion of visitors that were adults is higher than it was on Sunday. So we need to work out the proportion of visitors that were adults on each of those days. Now a proportion is just like a fraction. So in fact we've just done this in the previous part for Saturday. So for Saturday, there were 357 adults out of a total of 850 people. Now if you stick this into your calculator and then press the SD button, it will turn into a decimal for you, which is 0.42. That's going to be handy in a minute when we compare the proportions. So now let's do the same for Sunday. So we need the total number of people on Sunday, so let's add together the adults 330 and the children 420. That gives you a total of 750. So for Sunday, the proportion that were adults is the adults, which is 330, over the total, which is 750. And if you type this one into your calculator and then press SD to turn it into a decimal, you'll get 0.44. So you can see clearly the proportion on Sunday was actually higher at 0.44 than it was on Saturday. So Taylor's definitely wrong. So we just need to write a statement at the end, something like 0.44 is bigger than 0.42. For the last part of this question, we need to work out the amount of money that the theme park will receive for the ticket sales that weekend. We're given some information about the ticket prices. Adults are £35, but a child ticket is 15% less. So let's work out the price of a child ticket. To do this, we'll find what 15% is and then take it off. So let's find 15% of £35 first. So that's going to be 0.15 for the 15% times the £35 for the ticket. And that gives you £5.25. That means we need to take £5.20 off the £35. So £35 take away £5.25 gives you £29.75. So this number here is the price of a child ticket. So now we know the prices of both tickets, we just need to work out how many people attended. So for the adults, we've got these numbers here. So if we add those together, you'll get this number here, 687. And for the children, it's 493 and 420. Add those together and you get 913 children. So we've got 687 adults and 913 children. So if we do 687 adults times the price of an adult ticket, which is £35, you end up with this number here, £24,045. Let's do the same process for children, so there are 913 of them, times by their ticket price. That gives you this number here, £27,161.75. So all that's left to do now is just add up those two numbers, and you end up with a total money coming into that theme park at that weekend of £51,206.75. In this question, we need to work out an estimate for the mean mass of the sheep. Now, if you look at the table, we're given some information about the masses, but we're not told the exact mass of any of the sheep. We've got this first group here from 0 to 20, and there's a frequency of 6. This means there are 6 sheep in the mass range from 0 to 20. So what we're going to do is take the midpoint of 0 and 20, and just assume that all of those sheep have the same mass at 10. Then we'll do the midpoint of the next group from 20 to 40, that's 30. And then the middle of the next group is 50, and the middle of the final group is 70. So if we've got 6 sheep, that have a mass of 10 kilograms, we can do 10 times 6 to get 60. So all we need to do is multiply all of these midpoints by all of the frequencies. So 10 times 6, that's 60. 30 times 15, 450. 50 times 25, 1250. And 70 times 4 is 280. So if we add up all of these numbers here, we'll get the total mass of all of the sheep, which is 2040 kilograms. Then all that's left to do is divide this number by how many sheep there are, and we're told that in the question, that's 40 sheep, or you could add up the frequency column and that will also be 40. So 2040 divided by 40, which gives you 51 kilograms. In this question, we're going to solve this equation. We're going to start by taking away 2x from the left side and also 2x from the right side. If we take away 2x from the left-hand side, we've got 18x, take away 2x, 18 take away 2 is 16, so that's 16x, and then we've also just got this minus 5. And from the right-hand side, the 2x, take away 2x will give you 0, so there's just the 7 left. Now we can add 5 to both sides if you add 5 to the left-hand side and the right-hand side. If you do 16x, take away 5, then add 5, the 5s will cancel, so you've just got 16x. And then on the right hand side, 7 plus 5 is just 12. To finish this question, you need to divide both sides by 16. If you divide the left by 16, you get x. And on the right, 12 divided by 16, I'd use my calculator at this point, will tell you it's 0.75. So the answer to this question is 0.75. You may have also wrote your answer as 3/4, that will be absolutely fine too. In this question, we need to complete the table. And if you look at the table, you can see we've got the probability for red, but we're missing the ones for blue and green. Now, all three of these probabilities must add up to one whole. So if we do 1 take away 0.46, which gives you 0.54, this tells us the blue and green must add up to 0.54. Now let's look at this line here. The probability of selecting a blue is twice the probability of selecting a green. So let's say the probability of selecting a green, since we don't know it, is just x. Then the probability of a blue is twice as much, so 2 lots of that, so 2x. This means the probability of a blue plus a green, which is 2x plus x, is the same as that 0.54. So we could write 2x plus x equals 0.54. Now 2x plus x is just 3x, so it's 3x equals 0.54. So in order to find x, we could just divide both sides by 3, divide the left by 3 and you get x, and the right by 3 is 0.18. So we find that x is 0.18, so in the table where we've got that x, we can replace that with 0.18, and the 2x's can be replaced with 2 lots of 0.18, which is 0.36. So that's the table completed. For the next part of this question, we're told there are 350 counters in the bag, and we need to work out the number of red counters. To do this, all you need to do is take the number of counters in total, which is 350, and times it by the probability of a red, which is 0.46. Use your calculator for this and you'll get the answer 161. To do this, we're going to multiply all of the terms in the first bracket by all of the terms in the second bracket. So we'll begin with x times x, which gives you x squared. Then move on to x times negative 6, which is minus 6x. Negative 3 times x, minus 3x. And finally, negative 3 times negative 6, which is a positive 18. Here we just need to simplify. We've got a negative 6x, a negative 3x. That'll give you negative 9x. So the final answer to this question is x squared subtract 9x plus 18. For question 2, we've got a number in standard form and we need to write this as an ordinary number. So let's take the number 7.2, and since it's multiplied by 10 to the power negative 4, that's like dividing by 10 4 times. So let's divide by 10 once. That will give you 0.72 a second time, a third time, and a fourth time. So we end up with the number 0.00072. For the second part of the question, we need to take this number, 620,400, and write it in standard form. To write a number in standard form, you first of all need a number that's between 1 and 10. So for this one, we need to go for 6.204, and then we need to consider what power of 10 we multiply it by. So let's put the decimal point in between the 6 and the 2, and see how many times we need to multiply this by 10 to get back to the number 620,400. So it's 1 time, 2 times, 3 times, 4 times, 5 times. So it'll be 10 to the power 5. For this next question, you can just type all of that into your calculator because it's a calculated paper. your calculator will probably show you the answer, 9,600,000. The question says to give our answer in standard form, so we'll do the same process as we did in the last one. It's going to be 9.6 for our number between 1 and 10. And then we need to work out the power of 10. So let's place that decimal point between the 9 and the 6. And then it's 1, 2, 3, 4, 5, 6 times that we multiply by 10. So it's times 10 to the power 6. For the first part of this question, we need to take all of these x values here and substitute them into this formula here to get some y values. You need to be particularly careful with the negative numbers and make sure you put them in brackets. So let's start with x equals negative 4. So we're just going to copy out x squared plus 2x minus 5, but replace the x's with negative 4. Remembering that bracket. So instead of x squared, it's negative 4 squared. Then it's plus 2x, so it's plus 2 lots of negative 4, and then take away 5. Now since this is paper 2, you can just stick that straight into a calculator, and that'll give you the answer 3. So when x is negative 4, y is 3. Then we can move on to when x is negative 3, so it's negative 3 squared plus 2 lots of negative 3, take away 5, again straight into your calculator, and that gives you negative 2. Now in the question they've already done negative 2 and negative 1, so we'll move on to 0. So it's 0 squared plus 2 lots of 0, take away 5, which is negative 5. Let's put that into the table, and finally when x is 1, 1 squared plus 2 lots of 1, take away 5, is negative 2. So that completes the table. For part B, we need to draw the graph. So what we're going to do is take each of the pairs of values and plot them as coordinates. Let's start with negative 4, 3. That point goes here. Then negative 3, negative 2, that goes here. Negative 2, negative 5, that goes here. Negative 1, negative 6 goes here. 0, negative 5 goes here. 1, negative 2, and finally 2, 3. So if you've done this correctly, you'll end up with points that form this kind of U shape here. We need to join those up with a smooth curve, not straight lines, so something that looks like this. For the final part of the question, we need to use the graph to find estimates to this equation. Now notice the first part of the equation, the x squared plus 2x minus 5, matches the graph we just drew. The right hand side though just says 1. So since we drew y equals x squared plus 2x minus 5, we just need to draw y equals 1 and find where they cross. Y equals 1 is a horizontal line that goes through 1 on the y-axis, so something like this, and you can see they cross in 2 places. We just need to read off the x coordinates of those since we're solving an equation in x. So if we draw some lines down to the x-axis, you can see the left one here, I'd say that's about negative 3.6, and the right one probably positive 1.6. You'd be allowed to be 1 decimal place out on either of those. For this question, we're looking for the transformation that maps rhombus A onto rhombus B. So I can tell since the shape has been turned round, this one must be a rotation. So what we'll need to do is take some tracing paper, draw over the shape, and then we need to try and find the centre of rotation. Now in order to do this, you'll want to place your pen somewhere on the grid and turn your tracing paper and see if the shape A matches onto shape B. This sometimes takes a few tries, and with a little practice you'll get better at this. It turns out for this one, the point is here at negative 3, 3. So if I place my pen on that point and turn the tracing paper, you can see it does match perfectly onto shape B. We turn that tracing paper in a clockwise direction for 1/4 of a turn, so 90 degrees. So to write down this transformation, we would write it's a rotation. We went 90 degrees clockwise, and then we state the point we rotated it about, which was negative 3, 3. Now there is actually another possible answer for this depending on where you place your point. You could also have got all the marks for saying it's a rotation, 90 degrees anti-clockwise, but about this point, 0, negative 2. For the second part of this question, we're going to enlarge the rhombus A by scale factor 2 with a centre of enlargement 1, 2. So to start this off, we're going to mark on the centre of enlargement, that's at 1, 2, that's here. That happens to actually be on the shape itself. Next, we're going to go around each of the vertices of the shape and consider where they'll be enlarged to. So let's start with the one at the top here. To work out where it needs to go, we need to work out how you get from the red centre of enlargement to this green cross. And in this case, it's just up 1 square. So we're going to double that, so rather than going up 1 square, we're just going to go up 2 squares. So it ends up here. Then we'll do this one on the left. So to get from the red centre of enlargement to this blue cross, we go left 2 squares. So actually we'll double that, it should be left 4 squares. then the one at the bottom here. So to get from the red one to the orange one, we go down 1 square. So we actually need to make it double that, down 2 squares. And then for the one on the right, that's this purple one here. From the red one to the purple one is to the right 2 squares, so we double that, and it's to the right 4 squares. You can then join up all of these crosses, and you'll see the final rhombus. For this question, we need to write an error interval for the number 140 grams, rounded to the nearest gram. To do this, I like to draw out a number line. I'll place the number from the question in the centre, so that's 140 grams, and then we need to consider what goes at either end. Since this was to the nearest gram, we're just going to go 1 gram below and 1 gram above. So 1 gram below 140 is 139, and 1 gram above is 141. Now the error interval will be formed from the numbers that are halfway in between these, so this highlighted bit here. Halfway in between 139 and 140 would be 139.5, and halfway in between 140 and 141 would be 140.5. So those are the upper and lower bounds for the error interval, so it's 139.5 and 140.5. For this question, we need to find the perimeter of this parallelogram. To find the perimeter, we'll need to know the lengths of all of the sides. Now we can see the side DC on the bottom, that's 12, which means the side at the top, AB, must also be 12. So we're just missing AD and BC. Let's focus on this triangle here, DBC. We can see from the right angle in the question that this triangle is a right angled triangle. So let's label the sides. This 12 here will be the hypotenuse. BC on the right hand side will be the adjacent, and DB would be the opposite. Using this, we can write down that cos of 76 must be the adjacent, which we don't know, so we'll just call that A, divided by the hypotenuse, which we do know, that's 12. So we can rearrange this. If we multiply by 12 on both sides, we find the adjacent is equal to 12 cos 76. And that's one of the sides we were looking for. If you type this into your calculator, you'll find that the adjacent is equal to 2.903, and so on. So that's the length of BC up here, but it's also the length of AD over here. So to find the perimeter, we just need to add all of these up. So we've got 12, add another 12, add the 2.903, and the other one, and if you add all of those up, and then round to one decimal place like it asked for in the question, you'll get 29.8. For this final question, we're going to make m the subject of this formula. The first thing we're going to do is subtract 4 from both sides, so from the left side and the right side. If you subtract 4 from the left hand side, it will cancel the 4 that's already there, so you're just left with mx. On the right hand side, we've got a k there and we're going to subtract 4, so we just write k take away 4. Now on the left hand side, we've got mx, but we want m as the subject, so we want this x to not be there. So we're going to divide both sides by x. If you divide the left side by x, that will cancel that x and you'll be left with m. And the right hand side is k minus 4, but we're going to divide that by x, so we get k minus 4 all over x. And that's your answer to the question. You can now see that m is the subject because it's the term on its own. Thank you for watching this video. I hope you found it useful. There are some suggested grade boundaries here, but don't read too much into those. No one knows the real grade boundaries until after the papers are done. Check out the video I think you should watch next and subscribe so you don't miss out on future videos.